Welcome to Summarize Science. Today we are exploring a fascinating new study that used artificial intelligence to hunt for ghost galaxies in the deep reaches of space. In astronomy, these are officially called low-surface brightness galaxies, or LSBGs for short. They are incredibly difficult to find because they are so diffuse that they appear fainter than the background light of the night sky itself. While simulations suggest these faint galaxies should be everywhere, they remain severely underrepresented in our current catalogs. To fix this, researchers developed a way to use computer vision models to scan massive amounts of telescope data automatically. The core of this work involves something called domain adaptation. This essentially means taking an AI brain trained on one set of sky images and teaching it to work on a new, different survey. In this case, the models were originally trained on data from the Dark Energy Survey, known as DIAS. The researchers then pointed these models at the Kilodegree Survey, or KIDS, to see if the AI could find galaxies it had never seen before. This is a major challenge because different telescopes have different noise levels and color filters. By normalizing the images to physical units of surface brightness, the models were able to bridge the gap between the two different datasets. The result was a massive success, identifying over 20,000 low-surface brightness galaxies in the KIDS data. As you can see from these images, these galaxies look like faint, fuzzy smudges against the dark background of space. Among these discoveries were 434 ultra-diffuse galaxies, which are particularly strange. These objects can be as large as a massive galaxy like our own Milky Way, yet they contain a tiny fraction of the stars. The data shows that these galaxies follow a continuous structural sequence, connecting small dwarf galaxies to the larger ultra-diffuse ones. This suggests that they aren't a separate species of galaxy, but rather an extended family of the dwarf galaxies we already know. The study also looked at how these galaxies live and die based on their environment. Many of these galaxies are quenched, which is a fancy way of saying they have stopped creating new stars. This quenching seems most common in galaxy clusters, where the harsh environment likely strips away the gas needed for star formation. The researchers found that galaxies closer to the centers of clusters were significantly redder and less active than those on the outskirts. This confirms that where a galaxy lives has a massive impact on how it evolves over billions of years. To recap, this work proves that AI can successfully find faint galaxies across different telescope surveys without needing manual retraining. They successfully cataloged over 20,000 new objects and mapped out their life cycles in different cosmic environments. This is incredibly important for the future of astronomy. With next-generation telescopes like Euclid and the Vera Rubin Observatory coming online, we expect to find millions of these diffuse galaxies. The methodology established here provides a scalable pathway to process that mountain of data and finally reveal the hidden side of our universe. Thanks for watching Summarize Science.